Our last topic with these improper integrals is a special kind of integral. This is the integral from 1 to infinity of 1 over x raised to the p power dx. We are going to assume, this does not strictly speaking require, but for our work we're going to assume that p is greater than 0. Any integral in this form, so p is allowed to be any value bigger than 0. Decimal, fraction, whole number, doesn't make a difference so long as p is greater than 0. All right? So if any integral that meets this form with this requirement is called a p integral. All right? Now what I'm going to do is, all you need to know about this is the final result I'm going to get to. All you need to know is the final result. But what I'm going to do is show you where that result comes from. When I show you where the result comes from, you do not need to be able to reproduce where this comes from. All you need to be familiar with is what the final result is. But I'm going to show you where the final result comes from and how we get from here to there. So, suppose we're going to evaluate this. This is an improper integral. So if we're going to evaluate this, now remember that with respect to this integral, x is the variable, p is a constant. P is a fixed constant with respect to this antiderivative. P might be 5, p might be 7, but it is not the variable of the antiderivative. X is the variable of the antiderivative. Notice, by the way, what we're assuming is p is bigger than 0. If p is less than 0, then really what we have here is, suppose I have x to the negative 3. Then you could just read this as x to the third and be done with it. That doesn't really fall into the special category that we're going to need to have going forward. If p is equal to 0, this is 1 over 1. And again, that doesn't really lend itself to the discussion we're going to be using this for. So we're assuming p is bigger than 0. This is called a p integral. This is a improper integral, and I'm going to show you where the final result comes from. All you need to know is the final result. It's in the textbook, and it will be shown at the end of this video. So what you can do is just skip forward. If all you want is the final result and you want to memorize that, then that's wonderful. That's really all you need to do. You do not need to be able to reproduce this. Well, in fact, okay, so what we have here. This is the limit. This is infinity as an upper limit of integration, so b is going to infinity, of the integral from 1 to b of. Now I'm going to change this into exponential form. This is now x to the negative p dx. All right? So how do we work this? You evaluate the antiderivative as usual. You substitute upper limit minus lower limit, and then you evaluate b going to infinity. All right? So evaluate the antiderivative, substitute upper limit of integration minus lower limit of integration, and then evaluate the limit as b goes to infinity of that expression. So the procedure is straightforward. So even though you don't need to be able to do this, it probably shouldn't be too much of a challenge, but for the record, add 1 to the exponent. Now, negative p, I could write this as negative p plus 1. I'm going to change that around and write it as 1 minus p. It's a little more concise. So these are the same thing, negative p plus 1, same thing as 1 minus p. So I'm going to write that as x raised to the 1 minus p, divide by the new exponent we just created, and evaluate that from 1 to b. Evaluate at the upper limit of integration, evaluate the lower limit of integration. But I'm going to do something here just for a moment. I'm going to take this 1 minus p with respect to this limit. Now, with respect to the limit, b is the variable. X is a constant, p is a constant. With respect to this expression, b is the variable. This 1 minus p I can bring out in front of the antiderivative. X is still the variable of the antiderivative we haven't evaluated yet. But 1 minus p, that's a constant multiplier, and constant multipliers multiply along. So I've taken this out of the mix. That's just going to be hanging along here like an appendix. This is now x to the 1 minus p evaluated from 1 to b, and that's going to make this a little bit cleaner to work with over here. We still have this multiplier out front, but it's going to be a little bit cleaner over here. All right? So this becomes 1 over 1 minus p. This is the b going to infinity. And what do we have here? Evaluate the upper limit of integration. Remember, b is going in for x. P is a fixed constant. This is b raised to the 1 minus p minus 1 raised to the 1 minus p. All right? So what do we inherit out of that? Well, we still have 1 over 1 minus p as the constant multiplier multiplying along. I have evaluated the antiderivative. You substitute upper limit of integration minus lower limit of integration. I'm going to simplify that before I substitute in this b going to infinity. So I'm going to simplify this substitution here. This doesn't simplify. This is simply b raised to the 1 minus p. But this does simplify. 1 raised to any positive power. 1 raised to any power except 0. This is equal to this is equal to 1 for our purposes. Let's assume that's equal to 1. We'll see what happens here. There's one little detail, but we'll play with that. So then what we have out of that, as b goes to infinity, we have b raised to the 1 minus p minus 1. All right? Well, the limit of a constant is the constant, and so that's not a problem. This is at issue. The question is, what is this expression? How much is that as b goes to infinity? All right? So there are two possibilities. Well, how about if we do this? This is 1 over 1 minus p. I'm going to now use my infinity arithmetic shorthand notation. So this is, again, you don't need to be able to reproduce this, but this is the way to think of it. This is infinity raised to the power 1 minus p minus 1. Now, if this is infinity, then this doesn't make any difference. All right? All right? The question is, what is this value? Well, infinity, it depends upon what this exponent is, right? Let's just pick a number out of the blue sky. See, p can be any number bigger than 0. I'm going to pick a number out of the blue sky. I'm going to pick p equal to 5. All right? P equal to 5. 5 is, of course, George Brett's number, Kansas City Royals, George Brett. And so I'm going to pick 5. If p is equal to 5, then what do we have here? Again, let's just kind of do some little thinking on the side. So if p is equal to 5, this isn't officially part of our argument here, but if p is equal to 5, then we have infinity raised to the 1 minus 5. We have infinity raised to the negative 4. And what that means is it's 1 over infinity to the 4th power, which is 1 over infinity, which is 0. Say that again. If p is equal to 5, then this is infinity to the negative 4, which becomes 1 over infinity to the 4th, which is 1 over infinity, which is 0. So if p is equal to 5, this is 0. And what we inherit out of this is negative 1 times this expression. All right? Now, there's nothing magic about 5. We could pick another, just a random number, like, I don't know, 31. 31 was Brett Saberhagen, the great pitcher for the Kansas City Royals, Brett Saberhagen. And so if p is equal to 31, then we have p infinity raised to the 1 minus 31 is now negative 30. But that still becomes 1 over infinity to the 30, and that still becomes 0. Is it clear that at any number, anytime this exponent is negative, this piece vanishes to 0 and the result is negative 1? What kinds of values for p will cause this expression to be negative? When is 1 minus p a negative number? When is 1 minus p a negative number? That's when, subtract the 1 across, negative p is less than negative 1. Divide both sides by negative 1. Anytime p is bigger than 1, so 5, George Brett's number, 31, that was Brett Saberhagen's number, 16, that was Bo Jackson's number as a Kansas City Royal. So any number greater than 1 will cause this expression, right, will cause this expression to become 0. And what we inherit out of this piece of the puzzle is -1. We get -1 times this bit. All right? And so what we may say is this, and this now does become part of our argument. We say, case 1. If P is greater than 1, well, if P is greater than 1, we've seen this piece goes to 0. And what we get out of this is 1 over 1 minus P times -1. I'm going to distribute this negative into the denominator. So this becomes 1 over -1 plus P, but we can rewrite that. We can rewrite that as 1 over P minus 1. So anytime P is bigger than 1, this expression is equal to 1 over P minus 1. If P is equal to 5, George Brett's number 5, George Brett. If P is equal to 5, this is 1 over 5 minus 1. This works out to be 1/4. All right? If P is equal to 8, that was Jim Sundberg's number, the catcher, Jim Sundberg, when he played for the Kansas City Royals. If P is equal to 8, then 1 over 8 minus 1, if P is equal to 8, this is equal to 1/7. Anytime P is greater than 1, the value of this P integral is 1 over P minus 1. Now, what about case 2? What if P is less than 1? Let's not mix my words up. If P is less than 1, if P is less than 1, let's go back and look at this. I'm going to erase this. Let's go back and look at this expression of P is less than 1. Now, it's got to be bigger than 0 and less than 1. So what we're talking about are numbers like a half or a third or a fourth or 1/9 or 2/3. Let's assume P, let's just pick a number out of the blue sky. Let's do 1 over 3. 1 over 3. 3 was the great Jan Stenerud, the place kicker for the Kansas City Chiefs. And so let's do 1 over 3. So suppose P is 1/3. And again, we're just sort of thinking thinking unofficially here. If P is 1/3, then we have infinity raised to the 1 minus 1/3, which is infinity raised to the 2/3, which is infinity. And so if P is 1/3, this expression is infinity. Infinity minus 1 is still infinity. Infinity times I don't care is infinity. And so if P is equal to 1/3, this thing diverges. But it's not too hard to see, right? If X is equal to some crazy number like 63, I don't know, suppose P is equal to 1/63. It's a number bigger than 0, less than 1. So 1 over 63, the great middle linebacker Willie Lanier, Kansas City Chiefs. Okay, so what do we have here? This becomes 1 minus P is 1 minus 1/63, which is 62/63. So we have infinity raised to the 62/63 power. That's still infinity. Infinity raised to any positive power is infinity. And so this is still infinity minus 1, which is infinity times I don't care. Again, this diverges. It's not too hard to convince yourself that for any choice of P that's between 0, right, greater than 0, but less than 1, this thing diverges. There's one other case. What if P is equal to 1? If P is equal to 1, then we have 1 minus 1. We have 1 to the 0 power, and that has no value. This doesn't exist in the first place. If P is equal to 1, we have infinity to the 0, and L'Hopital's rule argument, we show this diverges. So that's the very long of it, very, very long of it. Here's the very short of it. This, if P is less than 1, if P is greater than 1, then the value is one over P minus 1. If P is less than or equal to 1, and it turns out we don't need to make this assumption. We could also throw in the negative values, but that's irrelevant to our point. If P is less than or equal to 1, then from 1 to infinity, 1 over x raised to the p dx diverges. All right. And so if p is bigger than 1, that's the value. If p is less than 1, the integral diverges. This is the part that you need to know. And I don't know about you guys, but I've taken exams before as a student. If you cannot smell a multiple choice question here, you're not sniffing very hard, because this is the easiest multiple choice question in the world to write. I'll give you this integral, and I'll give you p is equal to I don't know, 6, and I'll say, what's the value? 6 is the great Willie Wilson, the center fielder for the Royals, or Warren McVay, the running back for the Kansas City Chiefs. Anyway, so you can choose any value of p, and you could check to see, does it diverge? Does it equal to what? This multiple choice question writes itself. So, p integrals. You do not need to do all this stuff. That's just where it comes from. What you need to know is that the value of a p integral, if p is greater than 1, is 1 over p minus 1. If p is less than 1, it diverges.